Diyos. Maraming salamat po sa buhay at lakas na aming taglay, sa liwanag ng kaisipan at sa pagkakataon maipagpatuloy ang pag-aaral ng mga kabataan. Gabayan po ang bawat isa sa amin. Anuman ang bahagi na aming gagampanan, naway maging maayos at matagumpay ang pagtuturo at pag-aaral na aming gagawin sa araw na ito. Patawarin mo po kami sa aming mga pagkulang at pagkakasala, at sa aming paggawa, ikaw po ang aming makasama. Amen.
Ang bayan ko'y tanging ikaw, Pilipinas kong mahal, ang puso ko at buhay man sa iyo'y ibibigay. Tungkulin kong gagampanan na lagi kang paglingkuran, ang laya mo'y papantayan, Pilipinas kong hirang. Ang bayan ko'y tanging ikaw, Pilipinas kong mahal, ang puso ko at buhay man sa iyo'y ibibigay. Tungkulin kong gagampanan na lagi kang paglingkuran, ang laya mo'y babantayan, Pilipinas kong hirang. Ang laya mo'y babantayan, Pilipinas kong hirang.
Good morning, grade 11 students. Welcome to Valenzuela Live Facebook live streaming in Statistics and Probability. I'm Sir ROJAS from Bignay National High School, your live streaming teacher for today. Now we're going to discuss Lesson 2 and 3 of Quarter 4, entitled Identifying Test Statistic and Rejection Region. For our learning objectives, at the end of our session, it is expected that you will be able to identify the appropriate form of test statistic when A. The population variance is assumed to be known, B. The population variance is assumed to be unknown, and C. The central limit theorem is to be used. Number 2. Identify the appropriate rejection region for a given level of significance when A. The population variance is assumed to be known, B. The population variance is assumed to be unknown, and C. The central limit theorem is to be used. Let's have an activity first entitled, is it a Z or T? By typing the letter Z if the statement is a characteristic of standard normal distribution, and T if the given characteristic describes the distribution in the comment box. Let's have number 1. It is best applied if you have a limited sample size and is less than 30, as long as the variables are approximately normally distributed. Is it a Z or T? 5 seconds, go. Very good. The answer is T. Number 2. It is also applicable if you do not know the population standard deviation. Is it a Z or T? 5 seconds, go. Time is up. The answer is T. Let's proceed to number 3. This is the best to use in a statistical test if the population standard deviation is known. Is it a Z or T? 5 seconds, go. Very good. The answer is Z. Number 4, it is always used for normal distribution. Is it a Z or T? 5 seconds, go. Time is up. The answer is Z. Last number, number 5. This test is often applied in large sample and is greater than 30. Is it a Z or T? 5 seconds, go. The correct answer is Z. Well done, students. Before we move forward to the different test statistics, it is important to define the following terms. A population includes all of the elements from a set of data. A sample consists of one or more observations drawn from the population. Sample mean is the mean of sample values collected. Population mean is the mean of all the values in the population. If the sample is randomly selected and sample size is large, then the sample mean would be a good estimate of the population mean. Population standard deviation is a parameter which is a measure of variability with fixed value calculated from every individual in the population. Sample standard deviation is a statistic, which means that this measure of variability is calculated from only some of the individuals in a population. Population variance, in the same sense, indicates how the population data points are spread out. It is the average of the distances from each data point in the population to the mean squared. Since we already defined important things in identifying the test statistics in hypothesis testing, let us now answer activity number 2, entitled Find Mean, by determining the needed data for each given problem. Example number 1. A grade 11 researcher reported that the average allowance of senior high school students was more than 100 pesos. A sample of 40 students had a mean allowance of 120 pesos. At alpha equals 0.01 tests, it was claimed that the students had allowance of more than 100 pesos. The standard deviation of the population is 50 pesos. Find the population mean or mu, sample mean x bar, sample size small n, and the population standard deviation sigma. Based on the given, population mean is 100, sample mean is 120, number of sample 40, and the population standard deviation is 50. Again, mu is 100 pesos. It is the average allowance of the population of senior high school students. N equals 40, the number of students taken from all senior high school students. X bar is 120 pesos, the mean allowance of the sample. Sigma is 50 pesos, the standard deviation of the population. Next, for our second example, according to a cell phone company, the average price of a cellular phone in the Philippines is 12,999 pesos. However, in a sample of 20 customers randomly asked about the price of their cellular phone, data collected showed an average of 9,999 pesos and standard deviation of 7,999 pesos. Using alpha equals 0.05 level of significance, is there enough evidence proving that the average price of cellular phone is less than 12,999 pesos? The population mean is 12,999. Sample mean is 9,999. Sample size is 20, and the sample standard deviation is 7,999. Now it's your turn. For our next activity, you will type your answer in the comment box by identifying the population mean, mu, sample mean, x bar, sample size, n, and the population standard deviation, sigma, of the following sample problems. Number 1. The average number of ad clicks per day for Facebook before was 192,000, and the standard deviation was 100,000. 64 days after the redesign, the mean number of ad clicks per day was 200,000. 5 Find the population mean, sample size, and the population standard deviation. 10 seconds, go. Very good. The population mean is 192,000. Sample mean is 200,000. Sample size is 64, and the population standard deviation is 100,000. Next, for number 2, the average life of typical incandescent bulb is 1,500 hours, as claimed by a light bulb company, thinking that the average life of bulbs is less than what the company claimed. A client tested a random sample of 55 light bulbs. The rest resulted to sample mean of 1,300 hours and standard deviation of 25 hours. Is there enough evidence to prove that the average life of the company's light bulbs is less than 1,500 hours? Find the population mean, sample size, and the sample standard deviation. 10 seconds, go. Good job. The population mean is 1,500. Sample mean is 1,300. Sample size is 55. And the sample standard deviation is 25. Now that you are familiar with identifying the population mean, sample size, and the population standard deviation, let us have now the test statistics. Test statistics is used to calculate the p-value of your results, helping to decide whether to reject the null hypothesis. The larger the test statistic, the smaller the p-value, and the more likely you are to reject the null hypothesis. The table shows the appropriate test statistics to be used when population variance is known, population variance is unknown, central limit theorem, CLT, is to be used. Let us identify the appropriate test statistics when the population variance is known and the population is normally distributed, the value of sample size n is greater than or equal to 30, and the population standard deviation is known, then the test statistic is z-test. Next, when population variance is unknown and the population is normal or nearly normally distributed, the value of sample size n is less than 30 and the population standard deviation is not known, then the test statistic is t-test. Lastly, when central limit theorem CLT is to be used and the population may not be normally distributed, the value of sample size n is greater than or equal to 30 or considered sufficiently large and the population standard deviation is not known, then the test statistic is z-test. Variance is the square of the standard deviation, and the standard deviation is the square root of the variance. Hence, if the standard deviation is known in the problem, then basically, variance is also known. Now, let us identify the appropriate test statistic in the following illustrative examples. Example number 1. A study was conducted to look at the average time of students do exercise. A researcher claimed that in average, students exercise less than 12 hours per month. In a random sample size, n equals 110, it was found that the mean time students exercise is x bar equals 11.3 or sample mean hours per month with standard deviation or the sample standard deviation equals 6.40 hours per month. Since n equals 110, the sample size is large and variance is unknown. Hence, z-test is the appropriate tool. This is an example of central limit theorem. Next, for example number 2, an English teacher wanted to test whether the mean reading speed of students is 540 words per minute. A sample of 10 students revealed a sample mean of 520 words per minute with a standard deviation of 5 words per minute. At 0.05 significance level, is the reading speed different from 540 words per minute? The sample size n is 10, which is less than 30, and sample standard deviation 5 words per minute was given. Therefore, the appropriate test is t-test. This 10 example of population variance is unknown. Let us now proceed to our example number 3. A grade 11 researcher reported that the average allowance of senior high school students was more than 100 pesos. A sample of 40 students had mean allowance of 120 pesos. At alpha equals 0.01 test, it was claimed that the students had allowance of more than 100 pesos. The standard deviation of the population is 50 pesos. The sample size is 40, which is greater than 30. The population standard deviation is 50. Therefore, the appropriate test is z-test. This is an example of population variance is known. This time, let us have an activity number 3, entitled Which is Which, by identifying the appropriate test statistic to be used in each problem. For z-test, just click heart react. And if the appropriate test statistic is t-test, click like react. For number 1, a sample of n equals 25 is selected from a normal population. Sample mean is 56 and the sample standard deviation is 12. Which is which? 5 seconds, go. Time is up. N is 25, which is less than 30, and the sample standard deviation is known, which is 12. The correct answer is t-test, therefore, it's like react. For problem number 2, based on the report of the school nurse, the average height of grade 11 students has increased. 5 years ago, the average height of grade 11 students was 170 cm, with standard deviation of 38 cm. She took a random sample of 150 students and derived the average height of 165 cm. Which is which? 5 seconds, go. Time is up. N is 150 and the standard deviation is known. The correct answer is heart react, z-test. And lastly, we have problem number 3. Knowing from a previous study that the average of athletes is 80, an athletic advisor asked how his soccer players are academically doing as compared to other students' athletes. After an initiative to help improve the average of students' athletes, the advisor randomly selected 15 soccer players and found 85 as the average with standard deviation of 1.25. Which is which? 5 seconds, go. Time is up. N is 15 and the sample standard deviation is known. The correct answer is like react, t-test. Next lesson is identifying the rejection region and critical values. Let us define the following terms in illustration of rejection region. Rejection region or critical region is the set of all values of the test statistic that causes us to reject the null hypothesis. Non-rejection region or acceptance region is the set of all values of the test statistic that causes us to fail to reject the null hypothesis. Critical value is a point or boundary on the test distribution that is compared to the test statistic to determine if the null hypothesis would be rejected. The figure shows the rejection region under the normal curve for a directional, one-tailed, or left-tailed test. Notice that the entire area under the curve is divided into 2 parts by the critical value. The shaded region is the rejection region, and the unshaded part is the acceptance region. The critical region is at the left side of the acceptance region. Next, the figure shows the rejection region under the normal curve for a directional, one-tailed or right-tailed test. Notice that the entire area under the curve is divided into two parts by the critical value. The shaded region is the rejection region and the unshaded part is the acceptance region. The critical region is at the right side of the acceptance region. Next, the figure shows the rejection regions under the normal curve for a non-directional, two-tailed test. This time, notice that the entire area under the curve is divided into three parts by the critical values: shaded, unshaded, and shaded part. The rejection regions are seen on both tails, which means that have been equally distributed. The critical region is at the left and right side of the acceptance region. Steps in illustrating the rejection region. First is to identify what test is statistic to be used. Is the test two-tailed or one-tailed? Next, identify the critical value and computed test statistic. The computation of test statistic will be discussed next week. Last, sketch the graph and identify the rejection or acceptance region. Here is the commonly used level of significance and its corresponding critical values. For alpha, 0.10 and directional left tail test, the critical value is negative 1.28. And for directional right tail test, the critical value is positive 1.28. And for non-directional two-tail test, the critical value is positive negative 1.645, and so on. Let us solve example number 1. Assuming that the population standard deviation is known, sketch the rejection region for a two-tail test with 95% confidence. Thus, Z equals 1.68 fall in the rejection region. For step number 1, what test statistic to be used? The answer, Z-test distribution, since the population standard deviation is known. Is the test two-tailed or one-tailed? The answer, two-tailed test. For step number 2, identify the critical value and computed test statistic. Answer, for the critical value, use the table of critical values with 95% confidence, thus the level of significance is 0.05 and two-tailed. Therefore, the critical values is positive negative 1.96. For the computed test statistic, it's Z equals 1.68, which is given. For the last step, sketch the graph, and Z equals 1.68 fall in the rejection or acceptance region. The answer, acceptance region, since 1.68 is located in the middle of negative 1.96 and positive 1.96. Now let us have example number 2. Assuming that the population standard deviation is unknown for a randomly selected sample whose size is 11. Sketch the rejection region for a one-tailed test with 99% confidence. Thus, T equals 2.86 fall in the rejection region. For step number 1, what test statistic to be used? The answer, since the population standard deviation is unknown and the sample size is 11, the test statistic is t-test distribution. Is the test two-tailed or one-tailed? Answer, one-tailed test. For step number 2, identify the critical value and computed test statistic. The answer, given that the sample size is 11, it follows that degree of freedom equals n minus 1, which is 11 minus 1 equals 10. With 99% confidence level, thus the level of significance is 0.01. Using the t table, we find that the critical value is 2.764. It is the intersection of 0.01 and 10 degree of freedom. For the computed test statistic, it's t equals 2.86, which is given. For the last step, sketch the graph, and T equals 2.86 fall in the rejection or acceptance region? The answer is rejection region, since 2.86 is located at the right side of critical value 2.764. And lastly, for example number 3, a random sample of 250 bottles of juice drink were taken and was found to have an average content that is less than the company's claim that each bottle contains 500 ml of juice drink. Suppose that an appropriate test statistic revealed a value of negative 1.75. Is there enough evidence to support their claim at 95% confidence? Sketch the rejection region and locate test statistic value. For step number 1, what test statistic to be used? The answer, it is seen from the problem that the population standard deviation is unknown, but with a sample size of 250, which is large enough, we can make use of central limit theorem and consider the Z distribution. Is the test two-tailed or one-tailed? The answer, the phrase less than indicates that we have one-tailed test. For step number 2, identify the critical value and computed test statistic. The answer, with 95% confidence level, it shows that alpha equals 0.05 because alpha equals 1 minus 0.95, which is 0.05, and one-tailed or left-tailed. Therefore, the critical values is negative 1.645. For the computed test statistic, it's Z equals negative 1.75. For the last step, which is sketch the graph, and Z equals negative 1.75 fall in the rejection or acceptance region. The answer is rejection region, since negative 1.75 is located at the left side of critical value, negative 1.645. Now it's your turn. Let us have the what I can do part. 100 packs of potato chips were selected to verify the manufacturer's claim that the mean weight of each pack is 36 grams. At 95% confidence, are the mean weights of the sample and the population significantly different after knowing that the test statistic is 1.83. Sketch the rejection region and locate the test statistic. For step number 1, what test statistic to be used? Is the test two-tailed or one-tailed? 10 seconds, go. Time is up. Answer, Z-test distribution and two-tailed test. For step number 2, identify the critical value and computed test statistic. 10 seconds, go. Time is up. The critical value is positive negative 1.96 and the computed test statistic is 1.83. For the last step, sketch the graph and Z equals 1.83 fall in the rejection or acceptance region. 10 seconds, go. Time is up. The answer is acceptance region, since 1.83 is located at the middle of the critical value, positive negative 1.96. For your assignment, answer the assessment part of Quarter 4, Lesson 2 and 3 module. If you have any question, you may ask your subject teacher tomorrow during your follow-up discussion. That's all for today. Again, I'm Sir RODEL, your live streaming teacher today, leaving all of you with a message, stay safe, and may God bless us all. Thank you and goodbye.